So we just talked about having a triangle inscribed in a circle, and the triangle having vertices on the two opposite sides of, or the endpoints of the diameter, and the third vertex is somewhere on the circumference. And I told you that when this is the case, you always have a right triangle. And we did two derivations of this rule using just random degrees that we used for this central angle. Now with that same derivation, we can apply another rule. The rule is that if you have this being the center and you have some central angle, and I'm going to use these two same points and connect them with the opposite side of the circle, then this angle here, which I'll call theta, is always going to be double this angle here, which I'll call theta over 2. Now another way that they can show this on the exam is if they give you the diameter, and again let's say this is the center, and again I'm going to use this vertex and connect it with the opposite side of the circle. This angle I'm going to call it alpha this time, and this angle here will be alpha over 2. So again, let's do a quick derivation to see how this works. We have a circle, and this will be the diameter. Again, feel free to choose any degree you want. In this case, I'll choose 40 degrees. Again, using the idea that this is a radius and this is a radius, we have an an isosceles triangle. So these two angles will be 180 minus 40 divided by 2. So in this case, they would both be 70. Now, if this angle is 40, then this angle here would be 140. And again, we have an isosceles triangle using the two radii as the legs. And so these two angles would also be equal. And they would both be 180 minus 40 divided by 2, or 20. So again, the previous rule we discussed, 20 plus 70, this gives us a right triangle. But now let's look at the new rule. The central angle is 40, and this outside angle is 20. So the central angle is exactly double that outside angle. Just like we have here, we have alpha, and we have alpha over 2. Now if you imagine we have a diameter, and we do the same thing on both sides of the diameter, and what I mean by that is, if we say this is 40 degrees and this is also 40 degrees, we'll find that this is 20 and this is 20 as well. So this central angle in this case would be 80, and this outside angle would be exactly half that, which is 40. So again, the two rules that you need to know if you are given the diameter of a circle and the two endpoints of the diameter make up a triangle, this triangle is going to be a right triangle. And if we connect the third vertex with the center of the circle, this central angle will be theta, and that will be double this outside angle, which would be theta over 2.